Good.
Yeah, there we go.
All right. How's the West Coast?
Cool. I love it. It's an interesting place. There's a way to do it right. There's a way to do it wrong. So I'm glad I made the decision, to say the least.
Okay, great. So you see everyone,
Yeah.
except for Charles. Charles got something cooking. But I guess I don't want to waste too much time with, I mean, you know how we used to run it, and we're going to run it differently this time based on your actual recommendation. Can you maybe tell them what they should know as they're coming into this program? What helped you? And then we'll get into Wasti and John, and you could grill them for the interview.
I guess let's start with who I am. I don't know if everyone knows who I am, but we'll start with that. So my name is Brian. I graduated last year. Spent 2 years in the program. I did my undergrad in math and economics at Bucknell University. Came to Lehigh. Did this program. Focused mostly on kind of the machine learning applications in capital markets, I would say. Did some research, some capstone work. After my first year, I interned as a data scientist with a global manufacturing company. Pretty big volume of volume of data. The kind of high stakes, kind of lots of leadership visibility. And applying data science more in a kind of an R research and development role rather than more in like a product role. Continued working with them through my second year, kind of in a contractor-ish part-time role while still going to school. And then I eventually joined Thermo Fisher Scientific with their lab sciences group. So this is like COVID products. This is big laboratory kind of centrifuges and various laboratory equipment. So I sit with their data group on the sales and marketing side, and so our group, what we really do is we create data products. This is not we probably spend 95% of our time creating product, supporting product, and building product, and the other 5% is kind of ad hoc sales and marketing data analytics. I sit within the data science group. With my group of about 60, 75 people, we have a formal data analysis group. We have a data engineering group of software engineers who work on our internal sales software. And then there's our team. There's also, which is a little bit different, is a formal project management and product management office, which kind of is which you'll see at some of the bigger tech companies. It's a very similar management structure and how to kind of work in technology amongst the three groups. So that's kind of my background. Mm-hmm. I guess we'll address the what do you need to know part. Is that where
we're I mean, because you went quickly over it, but you mentioned you work on a few projects. But I mean, you did work on a few projects, right? You worked on the Ethereum, the smart contracts, a little bit of blockchain. Then you worked on the one having to do with sentiment analysis.
No, I did a little bit of blockchain work at the beginning. Picked up some of the reinforcement learning stuff. We kind of ran with that, and then at the end, kind of glanced over a little bit of the NLP work, build a little bit of the infrastructure there. Didn't do much of the ML stuff there. That was towards kind of the end as I was really pivoting to this new job.
But you did the one with Jordan.
So that was Factor. That was a Factor kind of thing.
And then you did the number 4, which is which got you some press, the interpretability with Arium.
Yeah. So I think the biggest thing is I want to take the two projects and split them up into 2 groups of projects. So the first two, so the 2 groups are going to be kind of more of a data analysis, kind of an ad hoc thing, and one's going to be more of a product. So interpretability is more of a product. With the dashboard, the whole backend system that was built there, and then the NLP is inherently it's a data product is really what it is. It's not kind of an ad hoc analysis. The other 2 are more kind of ad hoc Does it work? Does it not work? Is this true? Is it not true? So both of those projects, both of those types of projects require two different types of skill sets. And I'm not talking, can you type in Python? Can you speak SQL? Do you know the machine learning? It's more about the thought process of how you build things, and more importantly, build it to be sustainable. So let's start with the ad hoc work first. So that's referring to Factor, and that's referring to the Bitcoins, not the Bitcoin, sorry, the
Smart contract.
the smart contracts, Ethereum stuff. So that's kind of more of like a knowledge and domain base, right? Both of those are fairly unexplored. Well, Factor is more explored, but the way we did it was a little less explored. So you kind of had more free range. We kind of so you as the person on the project, right, need to be asking the right questions. You need to be investigating a lot of this stuff yourself. Stuff meaning the content. On the other side of the thing, building the product that was interpretability required much more software knowledge, and like, how do you get, the model to then store information on the back end, so then you have your front end can go call it, and how do you build all of that so that when you show up to the meeting with Professor Zoro, Harry, and other stakeholders, and they say, hey, we want to add 5 more features, how do you build it so that every week when they ask you to build 5 more features, it's just a flick of the switch. It's just 2 lines of code rather than having to rebuild everything every single week. So that's a completely different set of skills than kind of the ad hoc analysis. So I think that's a good way to understand kind of the difference between the two, and more importantly, the skill set required for the two.
Okay. So as they're coming in, how active should I will tell you that about half of the students right now, the new students literally, have started interviewing already. So I think the message is coming across that they need to be active, right? That was always your message.
Yeah, so the level of activity, that's good. I think the biggest thing is knowing that just because you have this, this MFE on your resume, or you have this background or this project, or the other thing is, just because you have machine learning buzzwords on your resume does not mean you're going to fly through every round and make it to the super day. That's just not going to happen. So that's an important thing to keep in mind. Given that, what I'm really saying is, if you write something on your resume, make sure you're able to speak to it to, at least the first level of thought, if not the second. And occasionally you might need the third level of thought if it's your big capstone project. If there's any publication, you did actual work in kind of in a corporate environment. So here's a good example. If you write XYZ technology and you're asked, what is XYZ technology? And you can answer that. Okay. And then they're going to ask you, and then you can't answer the question of how do we use XYZ technology? You might get into muddy waters there. So being able to speak to everything on your resume will at least get you through 2 rounds. They'll start barking at you, in the second, in the third, fourth, more technical rounds. But I can kind of cross that road when you get there. So I think the biggest thing is when you get the interviews, sure, that's the first door, but don't forget that there's another 3 doors that you have to get through. I've definitely stumbled through a bunch of technical interviews in various forms, whether it's embarking about some kind of machine learning thing that I didn't know, answering a math question I didn't know, programming question. So it's getting in the door is one, getting through the door is another. I think that's a good way to put it.
So in terms of a number, I know that I don't know if it was Jack or you, but one of you told me that basically from the time I showed up to the time I graduated, which is about 2 years, I had about altogether like 15 plus interviews. Is that a good number? Is that?
Yeah, that probably sounds about right, including internships and full-time opportunities. That probably sounds about right. Yeah, and of those 15, you probably make 2 or 3 super days, and of those, you'll probably have an offer or 2. It's a numbers game at the end of the day.
It is a numbers game. Okay, great. So why don't we get cranking here with the with Rusty and John? I sent you their resume. Do you have them, Brian?
Yep, I have them open here.
Who wants to go? John, you want to start?
I could give it a shot. I could give
Yeah,
it a shot.
okay. Brian, it's all yours.
Wait, I don't have John's resume. I
You
have
don't?
downloads. No. Apology if I mispronounced C Shang's resume.
Oh. Hold on.
I could send you mine if you would like.
Can you send it to him right now?
And
Yeah, let's drop it to this contact.
Oh, you're right. I sent you the wrong resume.
Drop it to that email would be great. Should we start with Wasti?
Yeah, why don't we start? Yeah, sure.
Save some time here.
Yeah, can get going. Can you hear me okay?
Yeah, I can hear you. So I'm not gonna get into, you know, more complex questions. I think the first thing I'm interested in understanding is your resume's got a bunch of stuff all over it. Meaning you have a little bit of data science, you have a little bit of, you know, traditional finance. I see the NLP. Can you, yeah, not an elevator pitch, but can you give me 1 or 2 sentences of kind of what you're looking to do, what your interests are, and kind of what your really short-term goals are?
Right. So the reason why it's all over the place was probably because I was figuring out what I wanted to do the whole time.
Yeah.
So just tried out a bunch of different things. So there's like valuation all the way to NLP. So currently I'm leaning more towards the data science route. I'll probably be doing the data science track as well for my MFE. So I want to go down the road of, you know, applied machine learning for finance problems, basically.
Cool.
Is the gist of it.
Okay. Given that, we're gonna go to we'll start with a technical question. Let's go to the second to last line of your resume. I see the word SQL here. Can you walk me through kind of the difference between a cross join and an inner join?
So a cross join would sort of merge all the different attributes, and an inner, did you say inner join?
Yep.
Yeah, an inner join would only merge the left table with the right and drop the rest.
Okay. Yeah, it's down the right path. The cross join will give you every combination of all the records. So if you have 10 records on the right and 10 records on the left, you're gonna get 100
Give you
records.
100, yeah.
And then the inner join is gonna give you only the records where the primary key and the foreign key match in both of the tables. Yeah, that's down the right path.
I should say I'm probably gonna take the SQL off because I haven't done it in over 2 years. So I'm gonna
well, yeah. So the solution there is either to keep it on and polish up the skills, because you will need that in a data science interview.
yeah, as of now, since I'm not doing it right now, I'm probably gonna drop it. But
Okay.
if I do get the time to get back into it, I'll put it back.
Yeah, I would recommend, you know, you don't need to be an expert, to be honest with you. But I would most certainly keep that on. That is, I use that every single day, probably hourly at this point, as a way of getting information from my databases into Python. So it's a bigger red flag if it's not on there than it is being on there. And clearly, you know, somewhat of what you're talking about. So I would keep that on there. Let's talk about a little bit of Python. Let's talk a little bit of Python here. Can you tell me the difference between a list and a tuple?
So a tuple is more of a list of lists. So a tuple could be basically different. I'm not exactly sure what the technical term for it would be, but a tuple, as my understanding, is basically, I think of it as a list of lists. So it could have multiple different lengths of attributes inside, whereas a list would be the same data type, one attribute.
Okay, not necessarily true. Lists can have various types of data types within it. The biggest thing is that a list is mutable, so things can be changed, and tuples are not mutable, so you have to recreate the data structure. They also carry less memory. Tuples tend to carry less memory than a list itself does. Let's talk about NLP. So you mentioned here applied natural language processing techniques. Can you name 1 or 2 or n number of the techniques you guys are using?
So As of right now, it's a very rudimentary counting words type technique. So we're not doing word to vec or anything like that yet, but that is the goal. So as of right now, we're using a function that's been developed called near regex, which basically measures the number of words within an n. So if you define an n, and you define two words, how many times do those occur within a 5-letter or five word distance or something like that? As of now, we've made n0 and just tried to find, do we have like predefined topics, and we're just trying to see how many times those topics occur over time and how that changes. So
Okay, cool. Can you tell me a little bit about the infrastructure of getting to the number of counts, right? Because from I see, 4,000 publicly traded U.S. companies, 27 years. I mean, the data is not big, but there's still some lift there. So can you walk me through how you go from the data ingestion point to that final number? And I'm looking for more of what the process looks like in Python. How do you get your information from the database? How do you automate this if you can? And just kind of walk me through what that technical process looks like in plain old English.
yeah, I'll do my best to explain the whole thing. I'm trying to remember where it starts. So first, the starting point is we were given a data set by the company that we're working with, and they had a data frame of year that had the year, the CIK, the company name, and their annual filing for that year, the 10K. It had the item 1 stripped from the rest of the 10K. There were a lot of them missing. So the first step was to drop the missing, like if the word count for that row or column is 0, we dropped that observation for now. Charles is working on getting the rest of the data. So the missing data rather. So after we filtered the data frame, we did some exploratory data analysis on it, seeing how many companies, how many 10Ks do we have per year. So we group by year, and then we see, how many of them do we have, how that changes over time. We did the opposite too. We grouped by company as well to see for each company, how many do we have on average. So do we have like 5 10Ks per year for per company or not? After that, all that data and like exploratory data analysis stuff, we moved into actually reading the 10Ks. So there was a way to get the 10K that we created a loop basically to read in every single 10K for every single year that we have. And then based on that, the near regex function, which basically works by you give it a word and it looks through the entire text and tries to find matches of that word. And if you define other words for it, it will try to match occurrences of those words occurring within a certain distance. So we set the distance to 0 so that we get, just the number of times it occurs. So it's basically like control Fing in a Word document or something.
Okay.
And then you try to get the number of, whatever your defined topic is, and you make a table of the number of counts that those occur. And then you try to see on a yearly basis, how does the mean, median, and like 25th percentile, 75th percentile of the number of occurrences of those topics change within a year and over the years.
Okay, cool. I see you've done a little bit of work in, stats and statistical ML. Can you tell me the assumptions of ordinary, or some of the assumptions of ordinary least squares regression?
Yeah, so the first assumption is that what we're trying to predict is linear. The second assumption would be there is no multicollinearity between the predictor within the predictor variables. Trying to think of I know there are quite a few assumptions that we typically make, especially for the linear regression. I'm trying to recall exactly.
Yeah, you're going down the right path. So multicollinearity, is there something in the errors that needs to be accounted for?
Yeah, so we assume that the errors are 0.
Yeah, so
probability.
the mean of the errors are 0, yeah.
Mean of the errors is 0, yes.
Yeah, and that they're identically and independently distributed.
Independently distributed, yes.
Yeah, cool. I guess one last question here. So again, so you said you've done some machine learning work, or you are exploring the ML
I
work? What does
would-
that look like?
Are you asking with regards to the NLP or just in
With
general?
regards to the relevant coursework, statistical machine learning.
That course is still ongoing. I haven't done any machine learning in that course yet. The extent of my machine learning experience has been like undergraduate level. So it's like .fit, .predict.
Okay, can you tell me kind of the difference between a classification ML problem and a clustering machine learning problem?
So classification ML problem is where when you have, for example, it could be like a binary, or you could have multiple different class types. So if you're trying to predict, say, is a person male or female, you could do like a logistical regression to see which one you predict. A clustering is, so you're basically trying, for classification, you're basically trying to predict a specified output. Whereas for clustering, for example, for k-means clustering, you're not given any idea about what, it's not labeled. So you don't know whether it's input or output. Your model will try to find groups that are similar to each other based on their characteristics.
Cool. Good job. Definitely, definitely answered most of my questions. With that said, Professor, let's transition. I got John, I got your resume. So
Thank you, Brian.
yeah, thank you, Wasti. Good job.
You got my resume, right? It's
Yep. John, I'm gonna ask you the same first question. Just kind of again, I understand folks are still exploring, trying to understand the various kind of technology, quant, data sciencey things. Just give me a kind of a 1 or 2 sentence TLDR about kind of what you're interested in, kind of what you're not interested in, and we'll kind of tailor the questions that way.
Oh, well, I mean, if I were supposed to just give a brief introduction, it would probably be that I was originally a business and finance major, but I wanted to apply some of my business and finance theoretical knowledge. And so I decided to double major in data science at NYU. And throughout the years, my interests have changed a little bit. And after taking a couple of machine learning and AI courses at NYU, I decided to focus on trying to apply some of those topics in finance. And my previous projects were guided towards more in the finance and economic side. But then as you can see, the transition of reinforcement learning, I also did have a similar reinforcement learning project at NYU Shanghai before. And then when I came here, I wanted to perfect that project a little bit more, and I was able to join the project number 7, which is I think it was the previous project you were in. But yeah.
Cool. So let's start off with a machine learning based question. So I see, I mean, obviously in DQ and the DQN algorithm, a little bit of deep learning there. I see you mentioned TensorFlow. Can you walk me through kind of how a neural network works? You can use a little bit of technical language, but let's start with a high level, and then I'll dive deeper in should we need.
Well, it really depends what kind of neural network we're talking about. Like when I specifically for like I guess for to make things a little bit easier and more understandable.
Just generalize. Let's say you want it. Let me give you an example. Let's say we have let's say we have X number of predictors, and I want Y, and I want to estimate Y, right? Tabular row data. How would you use walk me through how you would use a neural network and a little bit of the architecture there. Inputs, layers. Talk to me about how those things interact to finally get me an estimate of Y.
So I would probably start with an input layer, of course, and then I would move it into more layers, more dense layers, and then with each layer, I would probably have to put a activation function in it, which would probably be either like a ReLU or a linear or a sigmoid. And then it really depends on the amount on the on the last layer to see if I would use a sigmoid activation function. If there's only two outputs, then I would probably consider using a sigmoid. But then if there is more than two, I would probably use something more linear. And then to balance every single neuron, I would tensor, I would probably use backpropagation, right, which is pre-built in with TensorFlow. And then yeah, that's how I would probably train it.
Okay, can you, so you mentioned back propagation. Can you just walk me through what the point of what the real goal of back propagation is?
It's we are trying to find the local minimum of the, well, we can't find the global minimum on neural network. We're probably going to find the local minimum on the loss function for the neural network. And when we do back propagation, we're probably going to differentiate, find the derivatives, partial derivatives of each of the tensors, and then we're going to find the derivatives of each of the tensor. And it's probably going to be very iterative, I'm guessing, because well, I haven't done it personally, but it's going to be very iterative since the one tensor is going to be based on the previous tensor. So yeah.
Yeah, well done. Yeah, so we're taking the partial derivative of the loss function with respect to each of the weights.
Yes. Of the tensor.
And so the objective is to minimize the loss function by changing the weights in each of the layers. Well done. Good job. The reason I asked that question is because there's a lot of folks model.fit without actually knowing what model.fit does. It's very, very dangerous. You don't know what's under the hood. So that's why you'll see a lot of folks asking theoretical machine learning questions, trying to gauge your understanding of what's going on in the TensorFlow code under the hood. So very well done there. Let's talk about nothing that's on your resume. So I have, so let's put you in this situation. So you have to pay rent every month. It's $4,000, right? Okay. I give you two, there's two ways to pay rent. You can roll a dice. So you can roll a dice and you're going to get $1,000 times whatever face value you get. You get to roll the dice once. So you get, so for example, if you roll a 2, you get 2 times 1,000. That's how much money you're going to get to pay rent. The other option is you get to roll the dice 1,000 times and you get the sum of the faces. The question I have for you is, given those two situations, how would you pay? Which one of those two would you choose to pay rent?
I see. Okay. So I get to roll it 1,000 times, and then I get the sum of all of the faces.
Yep. So, for example, if you only had 3 times to roll it, and you got a 2, a 3, and a 4, well, then you would get the sum of 2, 3, and 4. That's how much money I would give you. Obviously, this is 1,000, so that's kind of, that extrapolates to this specific question I just asked.
Well, I mean, I'm guessing you have to use the expectation of rolling in between 1 to 6, which would probably be from a number 1 to 6, which would probably be 3. So for the first one, I would probably.
Sorry, stop right there. Stop right there. What's the expectation of a dice?
1/6 times the value of the dice. So 1/6. Wouldn't it be 3? We get the average of 3. Wait 1 second. Sorry, 21 divided by 6. 3.5.
Yep, 3.5 is an expectation of a dice. Okay.
3,500. So
and if it's so 1,000 times the expectation of a dice is 3.5, right?
Mhm.
And if we roll a dice 1,000 times, it's also 3.5 times 1,000. It's also both situations are 3.5, right?
Yeah, I'm guessing there wouldn't be any difference then in the first one or the second one. Yeah, in my yeah.
So if your life depended on your rent, right? What's the probability that you would get a 4 or greater given one roll? So if you have one roll, right? If you have one roll, what's the probability you're able to pay rent in this in the situation where you only roll once?
Is a 50%, right? For
Yeah, it's either it's either 4, 5, or 6, right?
yeah.
And then in the first case, what's the probability given one roll that you're able to pay rent? It's impossible, right?
In the first one, in which you get to roll it once, and then you whatever the face value is, you multiply by 1,000, you also be one half, right? Since
No, because right, we have to sum each dice roll. We have to sum across all the 1,000, right? So what I'm saying is we would most likely choose the case where you roll once and multiply by 1,000 because there's more volatility. And because there's more volatility, there's a greater chance of getting to that 4,000. And then, so that's one way to look at it. And the other way to look at it would be with more repetitions. So n is equal to 1,000 here. Central limit theorem brings our central limit theorem tells us that the outcome is going to trend towards the mean. And if the mean's 3.5, it's no good, right? So we would choose the first situation to maximize the chance of getting the 4, 5, or 6.
Brian, quick question. In that situation, are you saying that you get whatever number and you either pay rent or not, or you get that number towards your rent?
You pay the rent or not, right? So it's just kind of either it's happening or it's not happening type of situation.
Okay, so if you get 3,500, you're homeless. If you get 4,000, you're not.
Correct.
Gotcha. Okay.
Yep. So
gotcha.
that question is directly out of one of the banking interview, quant banking interview. That is nothing I made up. I see ANOVA. Can you, on your resume here with the price earnings ratio, February 2019 here, John, can you tell me kind of what ANOVA is, how it a little bit how it works? Can you tell me about the structure of the model and really what ANOVA is trying to capture?
I see. Okay, so I'm guessing with ANOVA, we're using the variance instead of the mean, similar to how we used in T statistics, or we use the mean to calculate if there is a relationship, if there's a possible relationship between two samples. And with ANOVA, we're using the variance, and we're calculating. We're calculating the. It's been a while. We're calculating the variance between the two samples and trying to see if they're correlated or not.
Yeah, so at ANOVA, right, we have a population, we calculate a grand mean, and we're trying to understand how each treatment group deviates away from the grand mean. So what it's basically for a hand wavy term, it would be a regression of means. So it's basically a regression of means. And we're trying to understand how each treatment deviates away from the grand mean. But yes, it's an extrapolation of a 2-sample t-test into an n number of treatments. I think I'll stop right there. Definitely asked you enough questions. Definitely well done on the machine learning parts of it. With that, I'll turn it over to Professor Zorno.
Sure. Let me see if students have questions for you, Brian.
Cool.
Yeah, I have a question. If you were basically restarting the program, right? Reset. What would you recommend yourself doing?
Yeah. So I'm gonna answer this.
Yeah.
I'm gonna answer this
Mind
question.
the data science aspect of it.
Yeah. I'm glad you mentioned that. So I am a little bit, how do I say this? I'm not the stereotypical person that comes out of this program, goes to banking and kind of goes down banking, quant, finance, that. So the answer I'll give you is more of the data science-y tech kind of answer. So obviously, I can't stress enough kind of the importance of knowing how to program. Jupyter Notebook is great, for the first little bit. the biggest thing though is the difference between true data science and building a data product, and then just living in kind of the data analysis, Jupyter notebook, here's my ad hoc analysis, here's the number, okay, done. Is understanding a little bit of software and how to build kind of an end-to-end product. I had that experience with reinforcement learning. You know, we had a cloud-based backend, you know, we had a front end that wasn't just a, you know, Power BI plug. There's Dash, which is basically a wrapper to HTML, CSS, a little bit of Flask in there. So building that, you know, end-to-end pipeline with users, with someone telling you, hey, I don't like how the UI works, can you change the back? You know, so building that end-to-end software in a, first of all, in a modular and atomic way. Atomic meaning you can just rip off chunks and kind of replace them, enhance them. So that learning how to do that in classwork is something that I would kind of really recommend for folks who are interested in kind of product-based data science. How do you do that is the next question. Well, so you'll get to stochastic calculus, and I'm pretty sure Professor Konis has you doing programming. A lot of the programming is it's stochastic calculus based, but you kind of start with a baseline of code and then you build upon it, and then you build a little bit more upon it, and then you build even more upon it, and then he says, go do it yourself. What we ended up doing is we just built a Python library that we would just call instead of copying, pasting code. So every time he said, go add this functionality, right? Go add this pricing instrument, go add this little thing, right? All I have to do is go into the source code of the package, add the line of code, and then literally import, you know, stochastic underscore calculations at the top of my thing, at the top of the notebook, and run, right? So that was super helpful in understanding how to build scalable. So really what I'm saying is how to build scalable code. Obviously this assumes you can code, obviously. So I think that's super helpful. What would have been super helpful. You'll learn it on the job pretty quickly. You know, you'll submit 2 things, your QA or boss will come to you and say, we know the business is coming to you in about a week with 35 more things that they want to add. Build this in a way so we can make those 35 things easier to add. So I think that's the biggest thing that I would kind of tell myself going back to square one.
And
Awesome,
a lot of
thanks.
the knowledge, thanks, Wesley, and a lot of the knowledge that you acquired in terms of coding in Python, because you're a math background, right? You don't have a coding background.
Yeah, I took one comp sci class. All of this is kind of self-taught, is primarily self-taught. It's not self-taught through data camp. It's not self-taught through a little, you know, a small little box on a free Python tutorial. It's building things.
It's through your projects, so basically because you had 4 projects literally, and that's what I
And then
understand.
and then internships and consult, and then the
Internship,
consulting
yeah.
thing that I did. So that, you know, when you have stakeholders, corporate stakeholders kind of putting you on the gun and making sure, you know, you have to stress test the product, you have to create unit tests. So you kind of, you don't know how to do any of those things. So you go to YouTube and you literally go to YouTube and Stack Overflow and learn from people who write these articles, Medium articles. These are people who are, you know, best practice FANG type of programmers who are building this. So so that's kind of how you do it. I see a question coming in. Did I have any experience prior to joining Lehigh? To be honest with you, prior to joining Lehigh, I took one class my junior year of undergrad. I remember vividly that during my senior capstone in undergrad, there was a chance to do Python and I ran away from it. So I could maybe print a hello world and do a loop my first day of Lehigh.
Did you have work experience before the MFE?
No, I went directly from undergrad directly to this program. I had an internship, but it wasn't in this. It was in procurement.
When you say like the interface or the UI, do you mean like HTML and CSS, or do you mean like using Python's like tkinter and those type of packages? Or
sorry, yeah, I kind of got parts of the question here. Say that one more time.
so when you say like the interface or the user interface for the, like for example, for the reinforcement learning, did you guys use like CSS and like HTML, JavaScript, and those like React and D3 libraries, or did you use like Python libraries or like TK?
So we used a package called Dash. What Dash is it's a wrapper to all those things. And it's kind of a base package. You can layer HTML, CSS on top of Dash, but it basically decreases the learning curve by a pretty drastic amount. The good news is that once you figure out Dash, going from Dash to pure HTML and pure CSS, it's pretty easy. It's nothing. It's much harder to learn Python and all that stuff than the front end languages. So really, don't worry about it. And as a data scientist, to be honest with you, working kind of given the environment I work in today, we have a whole group of folks who do dashboarding for us. So I take the data, I dump it into a database, I say, here's the URL, and then they connect it, and I don't even touch it. So, and then we have our software folks. I give them a cloud location, and then they use PHP to basically pull information from the cloud to a front end. I don't really. There's folks who are really good at it, and that's why they do it. And then obviously I'm not as good as that, and I focus on other areas. So we really have that segmentation, but we still have that team cooperation. So that hopefully that kind of answers your question. Both what it looks like in the project and what it looks like in industry.
And you said that you basically, after you get all of the data, you dump it into a database. Like, do you have to create your own databases or like with like ER diagrams, relations, and that?
Yeah. So sorry. So for reinforcement or kind of
Just day-to-day work.
Yeah. So that's a good question. So the question you have, and for everyone to understand, is you build a model. How do you deliver it to a client? How do you deliver it to a stakeholder? Do you send someone a CSV file? What does that look like? So we use AWS as our cloud provider, and we have various types of databases for various types of data. Not all data is tabular, so we'll use kind of an S3 type of environment to dump kind of images and non-structured data in there, and then or as an intermediate kind of staging location. And then for our final production type of work, we use Redshift. Doesn't matter. It's just a database, right? It's a tabular database. You basically write SQL against it. But yeah, so basically what we'll do is we'll have a script or sets of scripts that run our models. We have a layer that basically checks the output. So we have kind of an automated QA system on top of that. Make sure the